Yeah.
About the candle.
About the candle.
Yeah, did you find one?
I didn't. Somebody must have.
You have to share with your.
Where's that one candle that I used in class? Okay, stop, look, and listen here, people. Inverse again. Like I said before, we talked about direct variation. Well, inverse is kind of the opposite of that, and basically it's as one goes up, the other goes down. Yeah, proportionally, yes. Other goes down proportionally. Okay, and let me just review here. The equation we had for direct variation was y equals kx. Just put that in your mind. Because inverse variation, there's two to know. One of them will be more useful than the other. The first one, like this, is y equals, or let me see, y equals k over x. Okay, that's inverse variation. But usually when they talk about varying inversely, when they talk about that, they will usually use this formula. And this is probably the important thing to know. And it's actually a pretty simple one to remember. It's called the, I guess it's called the product rule for inverse variation. The product rule. In the sense that it looks like this. It is simply x1, y1 equals x2, y2. X sub 1, y sub 1 equals x sub 2, y sub 2. Give you a chance to write that down, and then we'll just actually probably look at the problem. The ones go together and the twos go together. And that will give you the inverse proportion stuff there. Let's see. Sure, here we go. Ready? Truck transportation. Write down this short yet simple story problem. I will try to. It's on page 420. Jeremy, do not give the answer until I say it. A truck driver is delivering goods from one state to another. Her speed, oh sure, they have to put a lady truck driver in there, is inversely related to her travel time. Speed is inverse to travel time. In other words, as your speed, which makes sense because as you drive faster, the amount of time it takes to get there goes down. So that's inverse variation. The faster you go, the less time it takes. All right. It says if she travels at 55, no. Sorry. Why is it? Lauren, did you set this thing? Because it isn't right. And, what's that? John didn't? At 55 miles per hour, it will take her 13 hours. How long will it take her if she goes 65? How long at 65 miles per hour? Question mark. So again, if you go back to the inverse variation equation, speed is inverse to the travel time. So you could change instead of saying x1, y1s equals x2, y2s, you could just say speed 1 time 1 equals speed 2 times 2. You know, they don't have to be x's and y's. If you fill in the blank there, let's say speed 1 times time 1 equals speed of the second one times time of the second one. You're going to get 55 is your speed. It takes 13 hours. That's going to equal 65 times what number? How long at 65 miles an hour? Question?
You read the last line.
How long at 65 miles an hour? Now, children, as you get to this upper level math, okay, the hardest way to do this would be to multiply 55 by 13 and then divide by 65. If you want kind of the shortcut way to do it, it would be to do this. You know you're supposed to have 55 times 13, but you know you're going to divide by 65 eventually anyways. If you divide this by 65 right away, you're going to save yourself some time in all that calculation. Because you can recognize that 13 goes into 65 how many times? 5. If you can see that, it just makes your life easier. 13 goes into 13 once, into 65 5 times, and 5 goes into 55 11 times. So it will take you, t sub 2 is 11 hours without having to do all that long calculating whatever thing there. Ain't that somewhat exciting? They'll also ask you is, would this be inverse variation? 4y, is 4 times y equal x inverse variation, yes or no? And again, this time you'd have to go back to that other equation where I said y equals, was it some number over k? K over a constant over x. Can you change this so that it looks like this? In other words, when you solve for y, what do you do? You divide by 4. You divide by 4. Is this in the same pattern as this? No. Okay, this is actually direct variation. Remember we talked about this. This actually is y equals 1/4 x. So this would not be inverse variation, it's direct variation. Or how about this one? 3xy equals 9. Can you solve that so that it'll look like this? Well, let's see. Let's divide by the 3 first. 9 divided by 3 is 3. So now x times y equals 3. Get y by itself, I would divide by x, divide by x. So I end up with y equals 3 over x, which is this. So yes, this would be indirect variation. Isn't that exciting? Look to page 421, please. Look at letter D. Write an inverse variation relating x to y when x equals 8 and y equals 1/2. Then graph the relationship. Thoughts on how to do that? What was it? X equals what? Y equals 1/2? Y equals 1/2, x equals what? 8? Again, going back, thinking about the inverse variation thing, which is this, y equals k over x. How would you write this into this? What would you have to do? Jeremy?
Put 1/2 equals k over 8.
Okay, substitute the numbers in for where they belong and find out what the letter k is, find out what your constant of inverse variation is. So 1/2 equals k over 8. What do I get if I solve that? Anybody? Lucas? 4 because, well, 2 times k is 2k, 8 times 1 is 8, divide by 2. K equals 4, so your equation is y equals 4 over x. And I know you're excited about this. Let's just take a look at inverse variation graph. What would that look like? Give me some points. What points would work there? First of all, x could never be what? X can't be 0. So we're never, ever, 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 ever is a line going to cross the y-axis. Because x could never be 0. It's going to approach the y-axis but never cross it. Give me some points. Well, if x is 2, y is 2, so I can put that point there. x2, y2. If x is 1, y is 4, right? If x is, what else can I do? 4, y is, well, if x was 1/2, what would y be? Yeah, 4 divided by 1/2 is 8, so here it would go up here. You are going to get this that looks like this. Ooh, I love it. It goes on forever, never touches the y-axis, but we're missing half of it because I didn't do any of the negative numbers. If I put negative numbers in here, what's going to happen? I'm going to get the same exact thing, except it's going to be on this quadrant over here. It's actually going to look like this. So is it really proportional? Does it proportional things have to be straight? Okay, interesting. Something to think about. And then look at problem letter E. I want you to do letter E for me right now. How much homework you get depends on if you get letter E right or wrong. I'm not going to tell you which though. I'm not going to tell you if you get it right, if you get more homework, or if you get it right, you get less homework. I'll tell you that. True. Sierra found an inverse relationship between her hourly pay rate and the number of hours she must work to earn a set amount. If she works 7 hours for $8 an hour, how long will she work at $10 an hour to earn the same amount? And then that would be one where you use that